Hey everyone, my name is Ryan and welcome to my new studio. I have moved in the past few weeks and so that's why I didn't create any videos, but today I am back and it's exciting to create another video for you. My studio is still, a work in progress. I'll make sure to do a studio tour once it's ready. So if it's a little bit noisy and the lighting is not as, not as good, please bear with me. So what we're gonna work on today is a very exciting tutorial. I've been wanting to be able to create a AR experience where you can stack AR objects on top of each other. So most AR applications or most tutorials that I found really focus on putting AR content on real world surfaces such as a table, the wall, maybe a couch if it's using LiDAR. But I didn't see any tutorials that show you how to essentially stack virtual content on top of each other. And so, for example, one use case could be if you have a furniture decorating or virtual try before you buy app where you can place a virtual table in a space and then place a virtual monitor on that table. And so in this tutorial, we're going to do a simplified version of that on iPad. So we're using our iPad Pro in this case. I'm using my 2020 iPad Pro with LiDAR, but we're using Swift Playgrounds. And so make sure you have Swift Playgrounds and an iPad. You can also do this in Xcode, if you have a Mac. But I hope you enjoyed this video and I hope it's useful to you. If you haven't subscribed yet, many of you actually watch my videos but don't subscribe. I would really appreciate it if you think this is helpful and you'll be, following along my channel. Please subscribe so you get notified as soon as I put new content online. So let's get started. So the first thing we're gonna do is I created a new Swift Playground, but to help us to stay focused, I also created an outline in this playground so that it's easier for me to, follow along. Okay, let's see, where is my trackpad? Okay, oh, there we go. Okay, great. So the first thing we're gonna do is we're gonna import our frameworks. There's 4 imports that we have to do. We're gonna say import playground support. Now this is needed because we're on playground. If you're using Xcode, you don't have to do this. We're gonna import RealityKit, we're gonna import ARKit, and we are gonna import SwiftUI. Again, as I mentioned, this is a SwiftUI tutorial, but most of this will apply to UIKit if you're doing that as well. Okay, so now that we've imported our frameworks, we're gonna scroll down to step 2, which is on the bottom. This was needed for Playground to actually run it properly. And we're gonna create our SwiftUI view, the main container that will hold our AR view. And so we're gonna call this struct content view, which is essentially implements the view protocol. And we're gonna create a var body some view. This is very standard SwiftUI code. I actually created a ultimate SwiftUI RealityKit tutorial. If you're not familiar with RealityKit and SwiftUI, maybe that's a better place to start. Okay, and then we're gonna return an AR view container. Now it's gonna give an error because we don't have an AR view container yet, but we're gonna create it. And then once we have our content view, what we're gonna do is we're gonna say playground page, let's see, playground page, current, set live view, and we are gonna create an instance of our content view and set that to the live view. Okay, so that's step 2. Now in step 3, we're gonna create our AR view container to make sure that so the reason why we have to create a container is Apple is still working on making UIKit elements and components available to SwiftUI. And so this is kind of interacting with UIKit. So this is a wrapper around an AR view, essentially. And so what we're gonna do is we're gonna create another struct, which is gonna be called AR view container, which is gonna be implementing UI view representable. And in this case, UI view representable has a few required methods that we have to implement. So we're gonna use Playground to our advantage and just have it fix things for us. So the first thing we're gonna do is we are going to provide a UI view type. In this case, we want it to be of AR view, right? And then we get more suggestions. So we're gonna select fix again. And I'm just gonna move the type alias to the top. just so we have things a bit organized, and I'm going to remove this extra white space. With make UI view, this is what's in charge of creating or instantiating the AR view and returning it to the container. And so here we're going to create our AR view. And we are going to use a constructor where we are providing a frame, a camera type, and if we want to automatically configure the session. For the frame, we're going to do .0 because it'll infer the frame from the playground. We're going to do an AR camera, and we automatically want to configure our session. This will do automatic lighting and plane detection and all that stuff. And then we are going to return our AR view. In our update UI view, we're not going to put anything. We're just going to leave it blank. In this tutorial, we will not be using our update UI view. Now, you can run it at this stage and you will see an AR view. I'm not going to run it because I already know what it's going to do, but it's a good practice to run your code, on intervals to make sure that it's always running and it's doing the right things so far. What we're going to do next is we are going to call a function that hasn't been defined yet. We're going to say enable tap gesture. Okay, this hasn't been defined, and that's what we're going to do right now. So under our struct, we are going to extend, or we're going to create an extension for our AR view. We're doing this because SwiftUI doesn't really have a good way of doing this yet. So this is kind of a hybrid between UI view way of doing things and SwiftUI, but this is what's currently working. I'm going to copy all of this in our extension because really that's what's going to happen in there. And so for our fourth step in this tutorial, what we're going to do is we're going to create a tap gesture handler. Just to back up a little bit to explain what we want our code to do. So when I tap on my screen, what I want to do is I want to see if there is an object where I tapped. If there's an object, I want to use that intersection between that virtual ray and the object to place another object at that location, at that intersection. If there's no such object when I tap on that, on the screen, creating a ray, then I just want to place a new object, a new AR object on a surface, a real world surface, if it exists. So just to reiterate, we're going to tap, see if it interacts with a AR object, an existing AR object in our scene. If it does, then we want to place a new object at that location, so on top of our AR content. And if it doesn't exist, then we want to see if there's any real world surfaces to then place our content. If there's no surfaces and there's no objects, we're not doing anything. Okay, and now maybe your application or your use case may vary a little bit, but this is what we're building in this playground. Okay, so what we're going to do first is we are going to create a new function called enable tap gesture. That way our error will disappear. And yep, there we go, it disappeared. We're going to create a tap gesture recognizer, which is a UI tap gesture recognizer. And we're going to have the AR view be the target. And for our selector, we're going to create a new selector function called handle tap recognizer. Okay. Now it's going to give an error because we don't have this function yet defined, but we will very soon. And then we're going to say self add gesture recognizer, and we're going to add our tap gesture recognizer to our AR view. Okay. It's very important to make sure that you add it, otherwise none of this code will work because it won't recognize the gesture. Okay, so we have that. Next thing we're going to do is we're going to define our handle tap. Now, I'm gonna write it out, without doing something specific for this, and you'll see that there's an error. And I'll show you how to fix that. Yeah, Euro tap gesture recognizer. Okay, so now that I've created this function, you're going to see an error, and it's going to say it refers to an instance method that is not exposed to Objective-C. And so we have to expose this method to Objective-C to fix that. And so what we're going to do is we're going to add add obj-c in front of that function keyword. And now the error disappears. And so now that we have our handle tap, this is where the majority of the logic will happen for our Swift playground. And so what we're going to do now is we're going to figure out where did the user tap on the screen. So on the 2D plane on the screen. And so to do that, we're going to say let tap location equals recognizer dot location in, and we want it to be in the AR view. Since we're extending an AR view class, self will refer to the AR view. Okay, now that we have our tap location, like I mentioned before, what we want to do is we now want to send a virtual ray that intersects with that tap location in 3D space. Okay, so this is a little bit new. I mean, I just figured out how to do this today, so this is also new for me, but it's very exciting that, you know, it's working. And so what we're going to do is we're going to say guard let ray result equals self dot ray through CG point. And I'll show you, and this is going to be the tap location. So we're going to send a ray, and I'm going to go into our help. Let's see. Okay, we're going to use our help tool here to know what this function does. This is actually possible in Swift Playground, which I didn't know initially that it was possible. So the summary says it determines the position and the direction of a ray through a given point in 2D space of the view. But the return definition is actually a bit more detailed. A tuple that represents a ray in AR coordinates that goes from the camera origin through the specified point on the screen. So where we tap, it sends a ray from the camera origin to that point, and it gives you the origin and the direction of that. So it gives you a position and a direction, and we need this to send a raycast to see if we're intersecting with any AR objects. So we're doing because this can return an optional, so we're just doing a guard let for that. And then we're going to do a raycast. So we're going to say let results equals self. Now this is where you have to be careful. We're going to do a raycast on the scene, or on the scene. So the raycast of the scene as opposed to just doing the AR view. I'll show you what we usually would do, and this is what we do if we want to do a raycast on an object. And so we're going to do self.scene raycast. And we're going to do it from an origin, or with an origin and a direction. I haven't used this in any of my tutorials before, if I recall correctly. So it's new for me and probably new for you. Okay, so here we're going to say ray result. And since it's a tuple, it has a origin and it has a direction. And so this is what I was mentioning, you know, in my explanation of what we're going to do. And I'm going to do direction. Okay. Now, this returns an array of, so I can actually show you what it returns. Let's do help. It's always good to use, you know, the help functionality. It returns an array of collision cast hit. And so we can look at the description, an array of collision cast hit results. Each hit indicates where the ray, starting at a given point and traveling in a given direction, hit a particular entity in the scene. Now, if you notice, it uses the word collision, which means whatever entities we use, they have to conform to the collision protocol. So it should have a collision shape. So that's a requirement. So once we place our content, we have to make sure that they have a collision shape. Otherwise, this will just ignore that entity. Okay, whew. So we're getting there, we're making progress. Next, what we're gonna do is we're gonna look at the first entity it hits, because that's the entity that's likely closest to the camera. And so that's the one we want. So we're gonna say if let first result equals results.first. And the reason why I'm doing this is because if the array is empty, first, I mean, it's an optional, so it can return nil. So we're going to do an if let. If we have a result in this array, that means we've actually intersected with an AR object. And so we're going to say raycast intersected with AR object. Place object on top of existing AR object. Okay, if we don't have a result, that likely means that, or not likely, that actually means that there's no objects that where we have tapped. And so the raycast then has not intersected with an AR object, and what we want to do is we want to place a new object on a real world surface if present. So if there actually is one detected, a plane, whatever. Okay, so let's work on what we're going to do is the scenario that you're familiar with for sure is the one where you place it on a tabletop or a wall, whatever. So let's work on that scenario first, because that's a little bit easier. When we have that, so when we don't have an intersection with an object, now we have to use a raycast to see if there's any real world surfaces. And so we have to create a new raycast, which is going to be let results equals self. And in this case, we're not going to use the self.scene.raycast. We're just going to use essentially arview.raycast. They're two different ones. And so, make sure that you notice this distinction. So here we have self scene.raycast, and here we have self raycast. We're going to use our tap location as the from point. We're going to use an estimated plane, and we're going to do any alignment. Okay, so any real world surface we can use to place the object, especially if you have LiDAR enabled. Okay, so what's next is we're gonna now look if there's any results, so meaning are there any surfaces that the raycast has detected. I'm gonna say let first result equals results.first, and if there is, then we're gonna get the position of that intersection with the real world surface, because that's where we want to anchor our content. And so we're going to say first result dot world transform dot columns. So this is a 4x4 matrix that we're essentially going deeper in to get the position. So this is not, so if you look at this, this will return essentially a 4x4 vector, but what we want it to be of type simd3 float value. And so essentially what it should look like, it should have this type. Okay, and it does not. And so what we want to do is we want to put it in a helper, and we're going to say simd make float 3. And this will convert that vector into the appropriate format or type. Once we have our position, then what we can do is we're going to say place cube. Now this function does not exist yet. I'm pretending it does. I'm essentially stubbing it out. And I'm going to say position. Obviously, we're going to get an error because it doesn't exist. We're going to create that right now. Okay, so that's essentially step 5. And so what we're going to do is we're going to create a new function called place cube at position, and this is going to be simd3 float value. So it's essentially an XYZ vector that we're doing. Okay, let's see. Okay, so what we're going to do now is we're going to create a simple cube that has a size of 0.3 meters, so 30 centimeters, and we're going to essentially place it using an anchor. And so we're going to create a mesh, which is a mesh resource dot generate box 0.3. We're going to create a simple material to make it look good. And we're going to make it white. We're going to put the roughness of 0.3, and we're going to make it true. Now, you can change these values, experiment, have fun with it, but this is what I'm using. And then we're going to create our model entity, which will use the mesh and the material. So there's several constructors that you can use, but we're going to use this one to create it. Okay, and now is the important part. You have to generate collision shapes for your model entity, otherwise it will not be detected by our array that we send out during handle tap. And so make sure you generate collision shapes. I'm going to set recursive to true. Next, we're going to create our anchor entity, which is going to be located at the point that we got from the raycast. And so we're going to say anchor entity using the world position. And so we're going to use our position there. And then we're going to add our model entity to our anchor entity. So add child, add our model entity, and then we have to add our anchor entity to our scene. So we're going to do that. Perfect. Okay, so this will place a very simple white cube of 30 centimeters, each side at that position. So now we don't have any errors. Now, what we still have to do is we have to actually do the scenario where the raycast does intersect with an AR object. And so that's what we're going to work on right now. So if it does intersect, then we can get the position of that intersection using our result. Let's get that. And so that's position. And this is again a SIMD3 float position or vector. But in this case, when you're, if this is your first time doing AR stuff, then it might be a bit complicated. But most objects or all objects in AR have a pivot point, or they're really their center of rotation. And so for a cube, their pivot point is in the center of the cube. So it is, if you were to place the cube at the intersection of another one, you would place it halfway because that's where the pivot point is. And so when you place a cube on top of the other cube, what you want is you want to offset it so that you have the distance from the edge to the pivot point, which is in this case half the size of the cube side. And so we have to offset our cube. Now you can change the pivot point of your, of your models if you have custom models, and then you don't have to offset them. But in this case we do. And so we're gonna, in this case we have to make our position a variable, not a constant, because we're gonna modify it. And then we're just gonna, now this is not really clean code because I should really have a, a defined constant for my size, but I'm just defining 0.3 here and 0.3 there, which is not good code. If you don't know why it's good, I challenge you to look it up and try to figure out why this is not, why this can fail. Okay, so why is this a bad thing? And leave a comment down below if you know why. Okay, so there we have our position. Next, what we're gonna do is we're gonna do the exact same thing. We're gonna place our cube. But in this case, we're gonna place our cube on top of the object. And so we're gonna use that, and we are gonna say position. Okay, so what we're gonna do is we're gonna do a quick demo to show you how this works. I mean, it's gonna work great, I hope. But then we're also gonna do a little bit more polish and a little bit more interesting stuff to wrap up this tutorial. So let's run this. I'm gonna select OK to access the camera. Okay, let's get it focused. Okay, so now we're placing our cubes, and as you can see, it is stacking. Oh, I made a mistake. It's not placing it properly. Where we're modifying the position, it should be, oops, not sure what happened there. It should not be position added, it should be position.y. So we only want to offset the y-axis, okay? And one thing that we're gonna do before we test it again is I wanna change the color, because just having white cubes, it's boring, it doesn't look good. And so what we're gonna do is we're now gonna extend our UI color class to generate a random color for us. So we're gonna say UI color, and we're gonna create a class function. That way we don't have to instantiate an object to be able to use this function. And we're gonna say random color, which is gonna return a UI color. Okay, let's see. So we're gonna select a few colors. We're gonna create an array of UI colors. And I mean, you can pick any colors you want. I'm just gonna do white, red, blue, yellow, orange, and green. I mean, you can pick any color you want. And then we're gonna create a random index to essentially pick a color each time we call this function. And this is pseudo-random, but this is random enough. Okay, and so we want it to be an integer, and so we're gonna use a function called ark for random uniform. And then we're gonna do a UI in 32, and then our colors.count. So we're gonna use the size of our array to generate a random, essentially an index that is capped at the size of the array. And then we're gonna return our colors random index. So this is a quick helper, class function that will enable us to generate a random color. Okay, so now we have this, then we're gonna update our placeCube method to use our newly defined function called UIColor.randomColor. Okay, so we fixed our offset where we only offset the Y axis of the position. We're placing a cube on top of some other content, and we now also extended our UIColor class to be able to generate a random color. Let's test it again and make sure everything looks great. Okay, so I'm gonna place a cube. Now we have blue. I'm gonna place it next to it, yellow, and I'm gonna tap on here. There we go. Oh wow, that's not very random looking. Oops, we got an error. Sometimes the playground gives errors. I'm not sure why. If you know why, please leave a comment. But as you can see, this works great. And this is how you can stack AR content using RealityKit and SwiftUI. Now, I really enjoyed creating this tutorial because it was something new for me. Most AR apps and most tutorials that I found, show you how to add AR content on real-world surfaces such as tabletops and walls. But I didn't see anything that showed you how to actually have AR content interact with each other. For example, stacking, AR content on top of each other. And so I think this is very powerful and has a wide variety of use cases. Now, if you have any ideas on how to use this, leave a comment down below on how you can use it. If you have any questions, again, always feel free to leave a comment or send me an email. If this video was helpful to you and you enjoyed it, consider giving it a like. And if you'd like to see more of my videos, especially if you want to dive deeper into AR, if you want to become an AR developer, or if you just enjoy watching them, consider subscribing. See you next time.